once you understand the derivative of the logarithmic functions, it's quite easy to find the derivative of exponential functions. Y equal exponential x. So if you express the x, is expressed the log y. Then find the derivative in the both sides of the equation. So this means dx and d dx log y. And the right hand side is quite easy. It becomes 1 because the derivative of the x with respect to x is 1. And the second right hand side is a y, but derivative with respect to x. Then we have to add the dy. So we call it, this is chain rule. So we have already studied. This is gonna be 1 over y. So it's becoming 1 over y dy dx. So from this equation, left hand side is 1, right hand side is 1 over y dy dx. So from this equation, dy dx equal y. So we prove that this equation, dy dx equal y. So this is exponential x. So this means exponential x function, the derivative, becomes exponential functions. We discovered important formula for the derivative of the exponential function. Then we'd like to move to the next topic. So number of unstable atoms. So this is separable equations. dN over dt. N is a number of unstable atoms. Number of the atom is decreasing because it's unstable. So decreasing rate should be proportional to number of the unstable atoms. If we have more atoms, the decreasing rate is increasing. Then we'd like to solve this differential equation. This is a separable equations. So n is collected here and dt is here. Then both sides integrate. And the derivative becomes 1 over n. It becomes log n. And the right hand side is minus kt plus c. C is integration constant. So if you express the n is the exponential minus kt plus c. So if you choose the n sub 0 is exponential c is n sub 0 exponential minus kt. So if you draw the t is a horizontal line and vertical lines at the t equals 0, n sub 0, the number is decreasing with time following the exponential function. Okay. Then for the last topic, the composite functions. So we have already used a chain rule. So, but it's a kind of review of the chain rule. When x is a function of t, so xt, and y is a function of x, yx, the new function y xt is called a composite function. Derivative of y with respect to t is given by dy dt is dy dx dx dt. So you could consider the dx is introduced. Then example. Following equations. Y is a function of t, but if you introduce the x, so y equal x to the fourth, and x is inside of the parentheses, 2t cubed plus 1. Then derivative easily calculated. dy dt is dy dx dx dt. dy dx is 4x cubes. And derivative of x with respect to t becomes 6t squares. Then substitute this x is here, you can get the answers. Very useful. You should be familiar with the derivative of the composite functions. When the f is a function of x, if you consider derivative of sine, cosine, trigonometric functions, you can add the df between, then d sine f df becomes cosine f. Also other cases you can introduce the df. Okay, this is the composite functions. Also composite function of the exponential case. Also you introduce the df. The exponential function becomes exponential function. Derivative of the exponential function becomes exponential function. Also in this case, df introduced. Derivative of logarithmic function is 1 over f. Okay, this is the end of this session.